So let's discuss that how do we deal with a matrix in case of 2D arrays. So basically, I want to tell you one thing, that 2D arrays is a form to store data, and when we store that data in form of two dimension, it get converted into matrix. Actually, matrix also stores the same thing. A matrix also stored a data, and when we go into the 2D analysis of Numpy, that is the 2D array, it get into a matrix. For example, let's first import numpy as num_np, and if I'll go further, then okay. So let's define the matrix 1. So yes, the matrix 1 could be written as what I should define. Okay, np.array in the same form, and now I'm opening the matrix. So this is the rule that first I will open. First I'll open the matrix. Then I'll add the first row and let the first row data be 2, 1. So then I'll proceed further, comma, and then I'll proceed further, and then again I'll open one more row, and then like 5, 9. Okay. Now matrix 2 is equivalent to np dot array, and then again I'll open the matrix, and then again I'll insert the data 2, 3, 1, and then again I'll move to the second row, and then I'll insert the data as 1, 0, 9. So yeah, here is it. So there are our two matrices. So for just verification, let's run matrix 1 and matrix 2. So yeah, exactly. So let's run it in different ways. Print matrix 1, matrix 2. Yeah. Okay, yeah. So as you can see that exactly it's getting to be as a matrix. Okay, so it's totally getting to be as a matrix. And okay, so let's just do one thing. Let's just write it down. So yeah, so our first matrix was 2, 1, 5, 9, and the second matrix was 2, 3, 1, 1, 0, 9, right? So yeah, so this was the matrix 1. So yeah, so this was the matrix 1, and this was the matrix 2. Now there are some things that is need to be analyzed. When we talk about the addition of a matrix, what are the rules? The rules is that if this matrix is of the form A cross B, then this matrix should also be of the form A cross B. That means, matrix 1, that if this is matrix A and this is matrix B, then the form of matrix A, or the order of the matrix, if A is also B, then B should be A cross B. Then B also should be A cross B in order, and and this is the condition for matrix addition. And I believe this is the one of the most important thing. And in case if we are doing this same in in case if we are doing the same thing in adding up the matrix, that is matrix 1 plus matrix 2, let's see that will it okay, so this is the matrix of form 2 cross 2, and this is the matrix of form 2 cross 3. So yeah, so their order are not same. So accordingly, if I'll see there, then one thing is very much clear, that that these two matrices can't be added. Right, yeah, so these two matrices can't be added. So from this case, I can tell one thing, that this must be printing an error. So matrix 2 plus matrix 1. So yeah, so here is it. So it's giving an error. So yeah, so matrix 1 plus matrix 2 is basically not possible. Not possible, since there it's like, since their order is not same, right? Okay. Now the next things comes the matrix multiplication. So let's say that the matrix 3 the matrix 3 that we get from the multiplication of matrix 1. Okay, here's a thing that is to be need to be noted. In case of matrix multiplication, we don't write it as star, we write it as at the rate. Okay, so matrix 2 cross matrix 3, sorry, cross matrix 2. So basically this is the symbol of cross. Okay, cross, that is cross or the dot product of matrix 1 cross matrix 2. Okay, so when I'll print matrix 3, okay, so let's just evaluate it that what can we expect in the, I mean, in the or the A cross B of the matrix. So let's see that what can we expect. So matrix 1 was so matrix 1 was 2 1 3 3 9, sorry, 5 9. Once I should verify it, so 2159 231 109, yeah. So okay, so cross 231109. So the first thing that is to be needed is that the rule for matrix multiplication. Rule for matrix multiplication. So the rule for matrix multiplication is that, as we all know, that if this is of the matrix of form A cross B, this is the matrix of form A cross B, and this is the matrix of form C cross D, then for it to be, it to be multiplied, then for the condition to be multiplied is that condition to be multiplied is that B should be equivalent to C. That is, the diagonal corner, the slant diagonal corner should be equivalent. Okay, so B should be equivalent to C. And there's one more thing that the okay, so if we are getting matrix C from this whole multiplication, then matrix C should be of the order. So the order of matrix C will be always A cross T, A cross T. And yeah, these are the rules for matrix multiplication, and these are these are the necessities that are very much necessary in order to multiply these two matrices. So okay, so yeah, so this and this should be same, and the future matrix will be of the form A cross D, that is matrix C. So accordingly, if we will perform the calculation, then this is 2 cross 2, this is a 2 cross 2 matrix, and this is a 2 cross 3 matrix. So yeah, so if I'll see there, then 2 cross 2, 2 cross 3, yeah, so 2 and 2 are equal, so this means that yeah, this is verified and we can perform the matrix multiplication. So this was 2159 multiplied by 231109, and as we know that matrix multiplication follows row multiplied by column method. So by row multiplied by column method, I'm getting the 2 2 2 2 4 1 1, that is 4, and 2 1 3, that is 6, and 2 1 2 1 1 9 9 11. Okay, so this is equivalent to 19, and this is 2 2, yeah, 5 to 10 to 9, yeah, 19. So this is equivalent to 15, since 530 and 900. Okay, so 530 and 91 and 51 and 99 81, that is 86. Yeah, so this is the answer that we can expect from the matrix multiplication. So let's just verify it. So when we will run, oh yeah, exactly. So here's the matrix that we are getting, and it's exactly the same thing as we can see there, that it's 5 6 11 19 15 86, 5 6 11 19 15 86. Yeah, so it's same. So it means that it really follows the matrix multiplication rules, right? So yeah, next thing is indexation of 2D arrays. So basically, when I'll okay, so as we have discussed, for the indexation for 1D array is same as list, but for in the case of 2D array, it's totally based on how we see the matrix. What do I mean is that if I want to print, let's say, matrix 1, although it's an 2D array. Okay, please note that matrix 1, there's nothing such as matrix 1, matrix 2. It's represented as a matrix and it's all 2D array. So matrix 1 and 0. And yeah, the thing that is to be noted is that whenever we write matrix or to array 2D and the indexation x, it means the representation. Okay. It means the net data of that xth row. Okay, yeah, so it means the net data of that xth row. That means that if we are doing matrix 1 0, that means this is matrix 1 and these first row is 2 comma 1, so the answer should be 2 comma 1. So let's print it. Yeah, so it's 2 comma 1. So yeah, so this is the data that we are getting from here, right? So okay, let's try to print matrix 2 and yeah, 1. So yeah, so we are getting 109 because this is 0 and this is 1. Okay. Okay, so let's try some more matrix. So let's try more. Let's do an addition. Okay, so 2 comma 1 comma maybe 5 and maybe 9 comma 56. Okay, so yes, so this should be okay, so let's name it as 4 and this as 5, matrix 5. So 5, yeah, so matrix 1 and matrix 5. So print matrix 4 plus matrix 5. Yeah, okay. So for a time to focus on here, let's index it. Okay, so np dot array. Yeah, okay, so we are getting the matrix to be 2 2 4 1 4 and 5 1 6 and 19 56 9 56 2 and 90. Yeah, for 5 1. Yeah, okay, so this is how okay, so now you can ask that how does it got multiplied in this case. Because the reason is again the same thing. The order of the matrix is 2 1 5 5 9 56, and as you can see that it's a 2 cross 3 matrix, and matrix 5 is 2 cross 3 and matrix 4 is also 2 cross 3, so that means it will get multiplied as we have discussed it here also. Yeah, so this is the rule for I mean the condition for matrix multiplication. Okay, so yeah. Okay, so the next topics are okay, so let's find out that what's the order. I mean whenever we talk about the finding out, okay, so finding out order, shape, size and dimension of matrix or 2D arrays using Numpy property, not function. Okay, so using Numpy property, so let's find out the shape, I mean the order. So yeah, so f, the order of matrix 1 is the order of matrix 1 is matrix 1 dot maybe shape. Yeah, so yeah, so the order of matrix 1 is 2 cross 2. Okay, so this is a 2 cross 2 matrix, and similarly if I'll talk about and the order of matrix 2 is matrix 2 dot shape, and yeah, this is a 2 cross 3 matrix, as we have already seen there that yeah, so this is a 2 cross 3 matrix, right? Okay, so this is a 2 cross 3 matrix. Now let's move on further. mtx. Okay, so yeah, okay, so finding out, okay, so let's find out the dimension of the matrix. So the dimension of matrix 1 and 2 2 are respectively are matrix 1 dot n dimension and matrix 2 matrix matrix 2 dot n dimension. So yeah, so the dimension of matrix 1 and 2 are both are 2. That means that this is a 2D array. Okay, so yeah, so this is a symbol or indication that it's an 2D array. Now the last thing is to find out the number of terms in the matrix. That is represented by what? That is represented by the size of the matrix. So let's find it out. So the size or the total number of data in, let's talk about matrix 2. Okay, in matrix 2 is matrix 2 dot uh, dot size. Okay, so what's expected? There are 2 cross 3, that is 6 data. So there are a total of 6 data, and yeah, so the order and or the total number of data in matrix 2 is 6. Okay, yeah, so this was all about the matrix operations in Numpy by Python. And that is, and that can be planted as the foundations or the base of machine learning in the upcoming topics. Okay, so yeah, so this was all about it. And yeah, so this was all about indexation of 2D arrays, and this was all about the finding out the shapes and size of the 2D arrays using its property, and this is how practically it's performed in linear algebra. So yeah, okay, thanks.